Question number 201. The error in the discharge dq by q to the error in the measurement of head dh by h over a rectangular notch is given by.
We know discharge over a rectangular notch q equal to 2 by 3 cd into l into root over 2g into h to the power 3 by 2. Okay, we know that formula. Then we can write q equal to k into h to the power 3 by 2, where k is equal to 2 by 3 cd l into root over 2g. Then we can write dq equal to k into 3 by 2 into h to the power 3 by 2 minus 1 into dh. Okay, so dq will be equal to k into 3 by 2 into h to the power half. This is equation number 3 and this is equation number 2. Okay, now if we calculate dq by q, that is the error in the discharge, that will be this value divided by this value. So if we calculate dq by q will be 3 by 2 into dh by d. So option number D is the right answer for this question. Question number 202. The error in the discharge dq by q to the error in the measurement of head dh by h over a triangular notch is given by. This is the fundamental equation. The discharge over a triangular notch q equal to 8 by 15 into cd into tan theta by 2 into root over 2g into h to the power 5 by 2. Okay, we can write q equal to k into h to the power 5 by 2, where k equal to 8 by 15 cd tan theta by 2 into root over tg. This is equation number 2. Okay, so dq will be equal to k into this 5 by 2 into h to the power 5 by 2 minus 1. Okay, so dq will be equal to k into 5 by 2 into h to the power 3 by 2. This is equation number 3. So if we calculate the error in the discharge dq by q, that will be equal to this value k into 5 by 2 into h to the power 3 by 2 divided by this value k into h into the power 5 by 2. Okay, if we calculate dh will be equal to 5 by 2 into dh by h, that will be the remaining. So option C is the right answer for question number 202. Question number 203. An error of 1% in the measuring head over the crest of the notch h will produce an error of what percentage in discharge over a triangular notch? The error in the head is given. Okay, so you have to find out the error in discharge. Okay, in case of a triangular notch, we know the error in the discharge dq by q equal to 5 by 2 into dh by h in case of triangular notch. Okay, so dh by h, that means error in the head is given 1%. So if we put the value, we will get dq by q equal to 2.5%. Okay, so option D is right answer. Question number 204. An error of 1% in measuring head over the apex of the notch h will produce an error of what percentage in discharge over a triangular notch? Same question. Okay, 1% error in the measuring head, so the error in the discharge will be 2.5%. Option D is right answer. Okay, and in case of rectangular notch, it will be dq by q equal to 3 by 2 into dh by h. It will be 1.5% if it is rectangular notch. Question number 205. A structure used to dam up the stream or river over which the water flows is called where? Option C is right answer. Question number 206. The difference between the notch and wear is that the notch is of bigger size and wear is of smaller size. No, the notch is of smaller size and wear is of bigger size. Okay, so option B is right answer. Disagree. Question number 207. A wear is usually made of masonry or concrete. Right, option A is right answer. Question number 208. The sheet of water flowing over a notch or a wear is known as nappy or vein. Option B is right answer. Question number 209. The top of the wear over which the water flows is known as seal or crest of the wear. Option A is right answer. Question number 210. The length of a liquid stream while flowing over a wear contracts at the end of the seal. Option C is right answer. Question number 211. According to Francis formula, the discharge over a rectangular wear is. Option B is right answer. 2 by 3 into CD within bracket L minus 0.1 N into H into root over 2G into h to the power 3 by 2, where n is the number of n contraction. Suppose this is a channel, okay, and here a wire is constructed. So here in this case the wire length is less than the channel's width, okay. So it will be called wire with one end contraction, okay. So number of end contraction will be 1. Here the length is contracted, okay. But in this case, look at this case, the wire length is short. Wire length is less than the channel width but contracted at both ends. So number of end contraction will be 2 in this case, okay. Question number 212. When the coefficient of discharge CD is equal to 0.623, then the general equation for discharge over a rectangular wire is. The formula for discharge over a rectangular wire is equal to 2 by 3 equal to CD, 2 by 3 into CD within bracket L minus 0.1 into N into H into root over 2g into h to the power 3 by 2. If the coefficient of discharge is equal to 0.623, the value will be, the discharge value will be 1.84 equal to L minus 0.1 into N into H into h to the power 3 by 2. Option A is right answer. Question number 213. When the end contraction of the wire are suppressed, then the number of end contraction are taken as 0. Option A is right answer. Agree. Question number 214. According to Bayesian's formula, the discharge over a rectangular wire is ml root over 2g into h to the power 3 by 2, where m is equal to 0.405 plus 0.003 divided by h. Option A is right answer. Question number 215. According to Bayesian, the coefficient of discharge varies with the height of water over the seal of the wire. Option A is right answer. Correct. Question number 216. The stipulative wire is a trapezoidal wire. Option C is right answer. Question number 217. The Francis formula for the discharge over a stipulative wire is 1.84 into L into h to the power 3 by 2. Option C is right answer. Question number 218. The discharge over a rectangular wire considering the velocity of approach is. Option B is right answer. Q equal to 2 by 3 into CD into L root over 2g into h1 to the power 3 by 2 minus ha to the power 3 by 2, where h1 is the total height of water above the wire is equal to h plus ha. H is the height of water due to velocity of approach and h is the height of water over the crest of wire. Question number 219. A wire is said to be narrow crested wire if the width of the crest of the wire is less than half the height of the water above the wire crest. Option B is right answer. Question number 220. A wire is said to be broad crested wire if the width of the crest of the wire is more than half the height of the water above the wire crest. Option C is right answer. Question number 221. In a broad crested wire, the discharge is maximum if the head of water on the downstream side of the wire is 2/3 the head of the water on the upstream side of wire. Option C is right answer. Question number 222. The maximum discharge over a broad crested wire is. Option D is right answer. 1.71 into CD into L into h to the power 3 by 2. Question number 223. In a shaft crested wire, the thickness of the wire is kept less than the half of the height of the water above the crest of the wire. Option A is right answer. True. Question number 224. A wire generally used as a spillway of a dam is ogee wire. Option C is right answer. Question number 225. The formula for discharge over a shaft crested wire and an ogee wire is same as that of a rectangular wire. Option A is right answer. Agree. Question number 226. When the water level on the downstream side of a wire is above the top surface of a wire, the wire is known as submerged wire. Option D is right answer. Question number 227. In a free nappy, the pressure below the nappy is atmospheric and the pressure above the nappy is atmospheric. Option A and C both are correct. Question number 228. In a depressed nappy, the pressure below the nappy is negative. Option B is right answer. Question number 229. The discharge of a depressed nappy is 6 to 7% more than that of a free nappy. Option B is right answer. Question number 230. The discharge through a siphon spillway is. Option A is right answer. Q equal to CD into A into root over 2GH. Question number 231. The frictional resistance of a pipe varies approximately with square of velocity of the liquid. Option C is right answer. Question number 2232. According to Darcy's formula, the loss of head due to friction in the pipe is 4FL V square divided by 2GD. Option D is right answer. Where F is the Darcy's coefficient, L is the length of the pipe, V is the velocity of liquid in pipe, and small d is the diameter of the pipe. Question number 233. The hydraulic mean depth or hydraulic radius is the ratio of area of flow and weighted perimeter. Option A is right answer. Question number 234. The hydraulic mean depth for a circular pipe of diameter small d is d by 4. Option B is right answer. Question number 235. The hydraulic gradient line is always parallel to the center line of the pipe. No, not always parallel to the center line of the pipe. Correct. Option B is right answer. Question number 236. The hydraulic gradient line may be above or below the center line of the pipe. Option A is right answer. True. Question number 237. The total energy line lies over the hydraulic gradient line by an amount equal to the velocity head. Option B is right answer. Question number 238. The hydraulic gradient line lies over the center line of the pipe by an amount equal to the pressure head. Option A is right answer. Question number 239. The total energy line lies over the center line of the pipe by an amount equal to the pressure head plus velocity head. Option C is right answer. Question number 240. The efficiency of power transmission through pipe is H minus HF divided by H, where H is the total supply of head and HF is the head loss due to friction in the pipe. Option A is right answer. Question number 241. The power transmitted through a pipe is, option C is right answer, W into Q within bracket H minus HF, where W is the specific weight in Newton per meter cube and Q is the discharge in meter cube per second. Question number 242. The power transmitted through the pipe is maximum when the head loss due to friction is equal to the one third of the total supply head. Option B is right answer. Question number 243. The maximum efficiency of transmission through a pipe is 66.7%. Option C is right answer. Question number 244. A compound pipe is required to be replaced by a new pipe. The two pipes are said to be equivalent if the loss of head and discharge of both pipes is same. Option C is right answer. Question number 245. Select the wrong statement. Option A. An equivalent pipe is treated as an ordinary pipe for all calculations. Right. Option B. The length of an equivalent pipe is equal to that of a compound pipe. Right. Option C. The discharge through an equivalent pipe is equal to that of a compound pipe. Right. Option D. The diameter of an equivalent pipe is equal to that of a compound pipe. No. Option D is the wrong statement. Question number 246. When the pipes are in series, the total head loss is equal to the sum of head loss in each pipe. Option A is right answer. Yes. Question number 247. A compound pipe of diameter D1, D2 and D3 having length L1, L2 and L3 is to be replaced by an equivalent pipe of uniform diameter D of the same length L as that of the compound pipe. The size of the equivalent pipe is given by, option D is right answer. L by D to the power 5 equal to L1 divided by D1 to the power 5 plus L2 divided by D2 to the power 5 plus L3 divided by D3 to the power 5. Question number 248. In case of flow through parallel pipes, option A, the head loss for all the pipe is same. Right. Option B, the total discharge is equal to the sum of discharge in the various pipes. Right. Option C, total head loss is the sum of head losses in the various pipes. No. So option A and B both are correct. Question number 249. The siphon will work satisfactorily if the minimum pressure in the pipe is more than the vapor pressure of liquid. Option C is right answer. Question number 250. A siphon is used to connect two reservoirs at different levels intervened by a high ridge. Option A is right answer. True. Question number 251. An air vessel is provided at the summit in a siphon to avoid the interruption in the flow. Option A is right answer. Question number 252. A nozzle is generally made of convergent shape. Option B is right answer. A nozzle is a tube of convergent shape of varying diameter due to which outlet velocity increases.
Okay. Question number 253. A nozzle placed at the end of a water pipeline discharges water at a high velocity. Option D is right answer. Question number 254. The power transmitted through the nozzle is maximum when the head loss due to friction in the pipe is one third of the total supply head. Option B is right answer. Question number 255. The diameter of the nozzle D for maximum transmission of power is given by small d equal to d to the power 5 by 8 f into L whole to the power 1 by 4. Option C is right answer, where capital D is the diameter of the pipe, F is the Darcy's coefficient of friction for pipe, and L is the length of the pipe. Question number 256. The water hammer in pipes occurs due to the sudden change in the velocity of flowing liquid. Option A is right answer. Agree. Question number 257. The magnitude of water hammer depends upon option A, elastic properties of the pipe material. Yes, right. Option B, elastic properties of the liquid flowing through the pipe. Right. Option C, speed at which the valve is closed. Right. Option D is right answer. All of the above. Question number 258. The pressure of the fluid due to hammer blow is directly proportional to the square root of density of fluid. Option C is right answer. Question number 259. The hammer blow in pipe occurs when the flow of fluid through a pipe is suddenly brought to rest by closing of the valve. Option C is right answer. Question number 260. The purpose of a surge tank is option A, to control the pressure variation due to rapid changes in the pipeline flow. Right. Option B, to eliminate water hammer possibilities. Right. Option C, to regulate the flow of water to turbine by providing necessary retarding head of water. Right. Option D is right answer. All of the above. Question number 261. The velocity of flow is same at all points in the cross-sectional area of a channel. No. Option B is right answer. False. Question number 262. According to Chase's formula, the discharge through an open channel is A into C root over M into I, where option C is the right answer. A is the area of flow, C is the Chase's constant, M is the hydraulic mean depth, and I is the uniform slope in bed. Question number 263. According to Manning's formula, the discharge through an open channel is A into M to the power 2 by 3 into I to the power half. Option B is right answer, where M is the Manning's constant. Question number 264. When the flow in an open channel is gradually varied, the flow is said to be steady non-uniform flow. Option B is right answer. Question number 265. A channel is said to be of most economical cross section if option A, it gives maximum discharge for a given cross section area and bed slope. Right. Option B, it has minimum weighted perimeter. Right. Option C, it involves lesser excavation for designed amount of discharge. Right. Option D is right answer. All of the above. Question number 266. The discharge through a channel or rectangular section will be maximum if its breadth is twice the depth. Option B is right answer. Question number 267. The most economical section of a rectangular channel is one which has hydraulic mean depth or hydraulic radius equal to half the depth. Option A is right answer. Question number 268. The discharge through a channel of trapezoidal section is maximum when the sloping side is equal to the half the width at the top. Option C is right answer. Question number 269. The most economical section of a trapezoidal channel is the one which has hydraulic mean depth equal to the half the depth of the flow. Option A is right answer. Question number 270. The discharge through a channel of circular section will be maximum when the depth of water is 0.95 times the diameter of the circular channel. Option D is right answer. Question number 271. The velocity through a channel of circular section will be maximum when the depth of water is 0.81 times the diameter of the circular channel. Option C is right answer. Question number 272. The highest efficiency is obtained with the channel of trapezoidal section. Option D is right answer. Question number 273. In open channels, the specific energy is the total energy measured with respect to the datum passing through the bottom of the channel. Option B is right answer. Specific energy is the energy per unit weight of the fluid at a particular section considering the bed bottom of the bed as the datum, where datum head is always 0. Question number 274. The depth of water in a channel corresponding to the minimum specific energy is known as critical depth. Option A is right answer. Agree. Question number 275. The critical depth for a channel is given by Q square by G to the power 1 by 3. Option B is right answer, where Q is the unit discharge through the channel. Option B is right answer. Question number 276. If the depth of water in an open channel is greater than the critical depth, then the flow is called turbulent flow. Option B is right answer. Question number 277. If the depth of water in an open channel is less than the critical depth, then the flow is called torrential flow, shooting flow, or supercritical flow. Option D is right answer. Question number 278. The flow at critical depth in an open channel is called torrential flow. No, it's called critical flow. Option B is right answer. Question number 279. The discharge in an open channel corresponding to critical depth is maximum. Option C is right answer. Question number 280. The most efficient section of a channel is trapezoidal. Option D is right answer. Question number 281. The rise in water level which occurs during the transformation of unstable shooting flow to the stable streaming flow is called hydraulic jump. Option A is right answer. Yes. Whenever a liquid of higher velocity is discharged into lower velocity zone, there is a huge rise in liquid surface, which is called hydraulic jump. Question number 282. The critical depth meter is used to measure the depth of flow in an open channel. Option B is right answer. Question number 283. In a venturi film, the flow takes place at atmospheric pressure. Option A is right answer. Question number 284. A venturi film is a film structure constructed across a channel by restricting its width. Option A is right answer. Question number 285. A structure whose width is less than the width of the channel is called film structure. Option A is right answer. Question number 286. A venturi film is used to measure the discharge of liquid. Option B is right answer. Question number 287. The coefficient of venturi film generally lies between 0.95 to 1. Option D is right answer. Question number 288. When a cylindrical vessel containing some liquid is rotated about its vertical axis, the liquid surface is depressed down at the axis of its rotation and rises up near the walls of the vessel on all sides. This type of flow is known as vortex flow. Option C is right answer. Question number 289. The rise of liquid along the walls of a revolving cylinder about the initial level is same as the depression of the liquid at the axis of rotation. Option A is right answer. Question number 290. When a cylindrical vessel containing liquid is revolved about its vertical axis at a constant angular velocity, the pressure increases as the square of the radial distance. Option C is the right answer. Question number 291. When a cylindrical vessel containing liquid is revolved, the surface of the liquid takes the shape of a paraboloid. Option B is right answer. Question number 292. The total pressure on top of a closed cylindrical vessel completely filled up with a liquid is directly proportional to the radius square. Option A is right answer. Question number 293. The total pressure on the bottom of a closed cylindrical vessel completely filled up with a liquid is the sum of the total centrifugal pressure and the weight of the liquid in the vessel. Option A is right answer. Correct. Question number 294. The flow of water through the hole in the bottom of a wash basin is an example of free vortex. Option C is right answer. Question number 295. Total pressure on the top of a closed cylindrical vessel of radius r completely filled up with liquid of specific weight W and rotating at omega radian per second speed at about its vertical axis is pi W omega square r square divided by 4g. Option A is right answer. Question number 296. The increase in pressure at the outer edge of a drum of radius r completely filled up with liquid of density rho and rotating at angular velocity omega radian per second is rho omega square r square by 2. Option C is right answer. Question number 297. The tangential velocity of water element having a free vortex is inversely proportional to its radial distance from the center. Option B is right answer. Question number 298. When a cylindrical vessel of radius r containing liquid is revolved about its vertical axis omega radian per second, the depth of parabola which the liquid assume is omega square r square divided by 2g. Option B is right answer. Question number 299. In the above question, if the angular velocity omega is doubled, then the depth of parabola will be 4 times. Option C is right answer. Question number 300. In question number 298, if the angular velocity omega is half, the radius of vessel is doubled, then the depth of parabola will remain same. Option A is right answer. Correct.